Hi class, today we're going to be starting our new lesson on scale factors and proportions. Go ahead and take out your ISN and set it up Cornell Note style. You should also go ahead and grab these 3 sheets of paper because we're going to use these and tape them in our notebook as we go through the notes. Let's just go ahead and get into it. Alright, for our first Roman numeral, we're going to do a quick recap and introduce some vocabulary words to you. So for A, you should write that a proportion is when 2 ratios, which is another word for fractions, are equal. We just wrapped up our unit on percents and proportions, so this should not be something that's foreign to you. Let's look at this example. Are 1/2 and 6/12 proportional? Well, in order to determine whether they're proportional, we have to see whether or not they are equal. So, I can see that 1/2 is already simplified. Okay, it can't get any lower than 1/2. Now, 6/12, I can simplify this further because both 6 and 12 can both be divided by 6. Okay, 6 divided by 6 is going to equal 1, and 12 divided by 6 is going to equal 2. So, we can see that both of these fractions are going to equal 1/2. So, are they proportional? Yes, they are proportional. Okay, let's jump right on forward. And please remember, at any point in time, if you need to pause the video, you certainly can. Now let's talk about scales. Go ahead and skip a line and write B. We're going to talk about where we can see scales in the real world. So a scale is basically anything that you use to either enlarge or size up or decrease the size down something. So we can see that scales can be used on maps, blueprints, recipes, pictures, on social media, and much, much more. On maps, we know when we look at a map and we see the continent of Africa, that the picture on the map isn't necessarily the size of Africa. It's a downsized model of what Africa would look like. So normally we would use something like a scale factor in order to determine, based on the map, how large the continent is actually. Okay? Likewise, on social media, when we post pictures on Instagram or on Pinterest or any other application that we use, they are a downsized version of the real thing. And the social media platform actually uses a scale in order to get the picture a certain size so that it can fit on your phone. Okay? So, scales are used in a variety of different ways, and we're just going to learn how to use scale factors to determine answers to questions. Skip a line and we're going to talk about scale factor. Scale factor is the ratio for 2 corresponding sides of 2 similar figures. So for example, in this picture, we have a little square that has 1-inch sides, and we have a similar square that has 5-inch sides. So the scale factor here would be 5:1, or 5/1. Okay? Now, in some of the examples that we're going to see, you may not always be given a picture. And in some examples, they may give you the scale factor and ask you to find a missing side or a missing measurement. So we're going to look into those type of examples right now. Go ahead and skip a line, and we're going to write our Roman numeral 2. We're going to do some scale factor problems. Go ahead and take your first example printed out problem, and right beside the letter A, go ahead and tape this down. You can get some tape from me, and we're going to get started. If you need to pause to do all this, go ahead and pause, and then we'll get started working the problem. Okay, so the problem says that the scale of a map is 2 centimeters to 25 miles. Okay? Use proportions to find the actual distance in miles for 12 centimeters on a map. So, they've given us the scale factor. The scale factor here is 2 centimeters to 25 miles. Okay? That's the scale factor. They're telling us to use proportion to set up two equal fractions to determine the actual distance in miles for 12 centimeters on the map. So basically, we can write our equal sign. We know what we're given in centimeters, but we don't know how many miles. So we can write the variable x for the number of miles. Now this is going to be like any other problem that we've ever solved. You're going to go ahead and bring down your equal sign. Okay. Then you're going to use the butterfly method, crisscross. So I'm going to draw an arrow from 2 centimeters to x miles, and I'm going to write that down here. 2 centimeters times x miles. Okay, because we're multiplying. Same thing on this side. Okay, I'm going to write 12 centimeters times 25 miles. Okay. Now, I'm going to multiply these two together because I can. And 12 times 25 is actually going to give me 300. Bringing down my equal sign directly under everything else. I know that I have 2 and I have x. So I'm going to have 2x. Okay? I need to find out what x is. And in order to get x by itself, I have to divide both sides by number 2, so I can get rid of the 2 on that side. 2 divided by 2 is going to give me 1, so I can bring down my x, and 300 divided by 2 is actually going to be 150. However, 150 what? Cotton candy balls? No. This question asks for the actual distance in miles. So our final answer is going to be 150 miles. That's our final answer. Okay? If we want to check our answer, we can actually plug 150 miles back into x, multiply this times 2, and multiply these two, and the number should equal up to 300. That's how we can check our work. Okay? Please remember, if you do not put your units for your final answer, it will be incorrect. So please make sure that you do that. Go ahead and grab your example 2, and you can flip on the back page because you've probably run out of space, and we'll get started on this problem. Okay, as you can see, before I got started, I set up my Cornell notes on the side, placed my letter B, and I went ahead and taped my problem to the page, and now I'm going to get started. If you need to pause to do that, go ahead and do it. The problem says Ms. Fersner drew a scale drawing of her classroom. If 3 centimeters on the drawing equals 6 feet, what is the real length in feet of wall AB? So first of all, I'm looking at wall AB. So I'm going to specify that by drawing that in. Okay? Have I been given the scale drawing? Yes, I have. The scale drawing for this figure is going to be 3 centimeters is the same thing as 6 feet. So 3 centimeters on the drawing basically means 6 feet in real life. So if this is my scale drawing, what's the real length of wall AB? Well, I know that wall AB is 12 centimeters. So I'm going to write 12 centimeters. But do I have that direct correlating number in feet? No, I don't. So I'm going to represent that by the variable x. Okay? Then I'm going to use the same butterfly method that I just used. So the first thing I'm going to do is bring down my equal sign. Okay? Then I'm going to write my first crisscross diagonal. 3 centimeters times x feet. Okay? Then I'm going to do the same thing on this side. 12 centimeters times 6 feet. I'm going to bring down my equal sign. Multiply 6 times 12, which is going to give me 72. And, of course, 3 and x are going to give me 3 times x. I have to get x alone, so what do I need to do? Divide both sides by 3. 3 divided by 3 is 1. Bring down x. 72 divided by 3 is actually 24, but my unit that I'm looking for is the real length in feet. So my answer is going to be 24 feet. Okay? Now, the next thing I want you to do is to take the last sheet that you've been given. Go ahead and write the letter C after you skip a line. Take this down, read the problems, do your work, show it. Don't mind if your numbers say 3 and 2. Just go ahead and scratch that out and make sure this is problem 1 and this is problem number 2. Read the directions, solve your answers. When you are finished, you need to come and show me your work, which should be in here, and your final answer circled, and then I will give you credit for having completed the guided notes. Once you're finished the guided notes, you can move on to the rest of the task sheet. Thanks, class, and happy scaling!